Okie doke, we're on to A2, which is going to be a little bit more with dealing with radicals and how to go back and forth between something called a rational exponent and radical form. Sometimes one versus the other might be easier to work in. Rational exponent comes from the word ratio, which just means a fraction. So it's the difference between writing something using a root symbol and then writing a base raised to a power that's written as a fraction. So like the 1/2 power, which is equivalent to the square root. So being able to go back and forth and understand that those two are saying the same thing. So that's our big picture for today, is being able to understand how to work with rational exponents. So let's jump in right away with the easiest or the most basic rational exponent, which is just a 1 over something. So being able to go back and forth. So a to the 1 over n equals the nth root of a, or a to the first. It might be nice to kind of think of it that way, because that's how this works. So the 1 on the top is the power that base is raised to, and the n, that denominator, is always the root, the radical root that you're taking. So when I look at this first one, 32 to the 1/5, what I am seeing, this bottom number is the root. So it's the 5th root of 32 to the first power. So there's one of them, so to the first power. So the 5th root of 32, I can go back to that power table that we had from the first lesson there and be able to find what that is, or we can do that on our calculator too. What number to the 5th power gives you 32? Well, that would be 2. So you being able to understand that the 1/5 power just meant the same thing as 5th root, super handy. So let's take a look and see how that works, so we can double check. So if I do the first way, so the 5th root of 32, it'll tell me 2. But 32 raised to the, and I'm just going to do 1 divided by 5, so the 1/5 power is exactly the same thing. So what we're showing is that depending on which way, what we might be doing, it might be easier to work with a radical. Maybe it's easier to work with a rational exponent, because then we can use exponent rules, right, which would be really handy. We need to be able to go back and forth and understand what that means. All right, so what would 64 to the 1/2 power then mean? Well, the 2, remember, is the root, so that's going to be square root. I'll put the 2 there for emphasis, even though we don't normally write that, of 64 to the first power, just 64. So basically it's the same thing as saying, what's the square root of 64? What times itself gives you 64? Think about that for a sec. That would be 8. So it's just what number times itself. I'm got to be super careful on letter C here. Just want to make sure we're clear. That negative, remember, on the outside just means, hey, take the opposite of your answer. The base here, what you are raising to the 1/4 power, is just the 81. Order of operations, we would do the power first and then take the opposite. So this just means opposite of, bottom number is the root again, so 4th root of 81 to the first power. So what times itself 4 times gives you 81? Well, that would be 3, so my final answer would be -3 then, because of the negative on the outside. So just be very aware of what your base is, order of operations, what we're doing first. All right, so how is letter D different? Well, the negative is on the inside with the exponents. So that means still 4th root, but of -81. Now, can I do that? Can I have a number times itself 4 times that ends up with a -81 for my answer? So it'd be like doing this. I'm going to multiply 4 of the same thing together, and I end up with a -81. Well, no, that's impossible, right? Because I can't take a positive number and do that, and I can't take a negative number and do that. I have to have opposite signs. So just be very aware. If there's parentheses, that means our actual base here, what we're raising to that power, is the -81. Whereas in letter C, it was not, because the negative wasn't inside parentheses. So check for that parenthesis to be able to tell. All right, so is this a negative base in letter E? Is it inside the parentheses? Absolutely it is. So we're going to be taking the cube root of a -64. Now, is that okay? Is it okay to multiply something times itself 3 times and get a negative answer? Absolutely. A negative times a negative times a negative is going to give you a negative result. So odd roots, totally fine. So what number times itself gives you 64? 3 times? Well, it's going to be a -4 then, because my base included that negative sign. So just be careful. Is it underneath or with the base or not? Look for those parentheses. Just like we did before with fractions with radicals, we can do the same thing with a rational exponent. I can think of it separately. This is going to be a cube root, so I can do the top and bottom separately. It's like saying I have a 1 to the 1/3, and then I have a 27 to the 1/3. 1/3, which translates into the cube root of 1 over the cube root of 27. So think about those fractions as the top and bottom as separate numbers. It's a lot easier. What times itself 3 times gives you a 1? Well, 1. The root of anything for 1 is 1. And then the cube root of 27, what times itself 3 times gives you 27? That'll be 3. Keep that power table handy. The more you look at it, I think the easier it's going to be to be able to deal with finding those and get a little bit more comfortable with them. So going back and forth between a rational exponent and then a radical. So if it's raised to the 1 over n power, I can just do that calculation pretty quickly. But we can also have not a 1 on the top. So a to the m over n. And again, I just want to emphasize here, the top number is the power that you're raising that base to. The n is the root that you're taking. So always think of it that way. In the first ones, it was just a 1, but we can break it up into those 2 different pieces. For a lot of the things that I'm going to do, this last version here is really handy. I'm going to take the root first and then raise it to that power. It's a little bit easier to do that calculation in your head. And we'll check these in our calculator too to make sure that they make sense for everybody. All right, so 25 to the 3/2 power. So the 2 is the root, and the 3 is the power that I'm going to raise that answer to. All right, so what does that mean? Because it looks kind of confusing. So this is going to be the square root of, I'm trying to keep my color coding here, so square root of 25. And I know normally you probably wouldn't write this 2 there, but just to emphasize, that's the root. And then I'm going to take that answer and I'm going to cube it. It's a lot easier to make your number smaller first, right, and then raise it to the power. So square root of 25, well, that's just 5. And then I have to cube that answer. So 5 cubed, 5 times 5 times 5 is 125. All right, let's double check on our calculator and see if that makes sense. So we're going to do 25 raised to the 3 divided by 2 power. Oopsies. Forgot my divide symbol there. I thought I typed that in there. All right, so 125. There you go. So it looks kind of mystifying when we think about that. But just do the root first and then raise it to a power. So what would 27 to the 2/3 power be? Which number is the root? Always the denominator. So that's the root, the radical, and then the 2 is the power that you're going to raise that answer to. So it's kind of our shortcut notation for how we want to write these rational exponents. So cube root of 27. And then I'm going to take that answer and raise it to the 2nd power. So just follow your order of operations. Cube root of 27. What times itself 3 times gives you 27? Well, that would be 3, and then I have to square it. So 3 squared would be 9. So it's not so bad once you know what you're looking for. It's just understanding what the notation is telling me. All right, how do you feel about this next negative sign? Are we feeling good with that? Is that okay? Totally fine. It's on the outside. What is your base? The base is just the 16. So order of operations, I'm going to start with that 16. That's my base that I'm going to be working with. So the base is 16, and what power am I going to raise it to? All right, well, I've got my root of 2, and then I'm raising that to the 3rd power. So my power is the 3. And then that negative sign just going to be floating on the outside. All right, so I've got the square root of 16. So again, emphasize the 2. I know you don't have to write it. And we're going to be raising that to the 3rd power. And then we're just going to be taking the opposite. All right, so order of operations. Let's start on the inside. Square root of 16, that is 4. What times itself? Right, 2 times. And then I need to cube that and then take the opposite. So 4 cubed, 4 times 4 times 4. That would be 64, and then I take the opposite. The very last thing is take the opposite because I'm doing everything associated with the power first. So that fractional exponent told me to square root, then cube, then take the opposite. All right, so how is letter D different than letter C? Well, once again, that negative is on the inside. It remains to be seen if that's something I can do. But the base then, what I'm actually doing the operation with, is going to be the negative 64 because it's on the inside of those parentheses. Always look for those grouping symbols. Grouping. Sounded interesting. Grouping. All right, so the root, and then we have our power. So same as in the last ones. So we have our cube root. So cube root of negative 64. And then we're going to take that and raise it to the 2nd power. All right, so can I do this? Is this legal? It's a negative times a negative times a negative. Cube root, totally fine to be negative. So what times itself 3 times gives you negative 64? Well, that would be negative 4. And then I have to square that answer, so be careful. A negative 4 times a negative 4, ultimately our final answer here is going to be a positive 16. So because I was squaring, I was taking a negative times a negative. So just always be aware of what number is it that I'm working with. All right, so let's see if this one's going to be okay to do. So negative 36 is my base. Notice the negative's on the inside of the parentheses. So it's asking me to do a square root and then cube. So that's my power. Let's see what that looks like. So I've got a square root of negative 36, and they're asking me to cube my answer. All right, now I want you to take a peek underneath. Is there any number times itself, squaring, that's going to give you a negative 36? Is that legal? Does that make sense? Nope. Back here in letter D, it was okay because there were 3 of them, right? Odd root. You can definitely get a negative number with 3 things multiplied together times itself, but not with 2. It doesn't work. That is impossible. That would be no solution. So just like before, we always have to be thinking about what's okay to use, what's going to work and what's not going to work. So when we're doing these fractional exponents, it's all about that base. Little Megan Trainor shout out for you there. All right, so for the next ones, we're going to talk about negative exponents. I know we've done negative exponents before. It just means reciprocal, right? 1 over. We did that back in chapter 5. But we can do that with fractional exponents as well. It just means it goes in the opposite location. And again, you can still convert it over into radical form if you'd like. So just think about where they need to end up. All right, so when I look at this first one, 81 to the negative 3/4, that negative sign is not meaning a negative number. It's up in the exponent, it means reciprocal. So this is going to be 1 over 81 to the 3/4 power. I'm going to put those values where they belong right away. All right, now remember, the bottom number in a fractional exponent is the root still, and the numerator is the power that I'm going to raise it to. It's just that that number answer is going to be in the denominator of this fraction. So I'm going to have 1 over, and I'm going to be taking the 4th root of 81, and then raising it to the 3rd power. So the only difference between what we were doing before and now is where's your negative sign? It's in the exponent. If your exponent's negative, that means reciprocal. That's kind of the key word that we think of when we're thinking about how we calculate these negative exponents. All right, so let's do that calculation then. So the 4th root of 81, use your power table. What times itself 4 times gives you 81? Well, 3. And then I have to cube that answer. So that would be 1 over 27. Definitely my preference that you leave these as fractional exponents. It's or a fraction answer, much easier than trying to do a decimal answer. All right, so take a peek at the next one. See how we have that negative sign up in the exponent? Once again, that means reciprocal. So that means 1 over 36 to the 3/2 power, reciprocal, right? So the negative means 1 over, or reciprocal. So the 2 is my root, and the 3 is the power I raise it to. So we're going to do the same thing we were doing before. So 1 over, see if you can rewrite this. What are we going to be doing on the bottom? See if you can pause the video, write what that radical should be on the bottom that we're trying to evaluate. So square root of 36, and then take that answer and cube it. All right, so what is the square root of 36? Well, that's 6, and then cubed. So 6 cubed, 6 times 6 times 6. Go ahead and check your power chart. That would be 1 over 216. So again, please leave your answer as a fraction. It's just a lot easier than having some tiny little decimal. Alrighty, let's take a look at a fraction. Yikes, we got that negative. It means 1 over. So technically it means 1 over 64/25 to the 3/2 power. Now, for me, that's hard because there's going to be 2 things in the denominator, right? So dividing by a fraction like that, same as multiplying by the reciprocal. For me, what's easier right from the get-go, just do reciprocal of this fraction. So 64/25 to a negative exponent means the same thing then as 24/64 raised to the positive 3/2. It means reciprocal, 1 over. So just do the reciprocal of that fraction, and then you can do the top and bottom separately like we were doing before. So we have our root, which is going to be the square root, and then we have our power that we're going to raise it to. Let's just do each number separately. So I'm going to do the square root of 25, and I'm going to do the square root of 64, and then I'm going to take both of those numbers and cube them. So just think of the top and the bottom separately. It just makes life a lot easier. So I did reciprocal because of the negative exponent, and then I'm taking each part to that root, and power. All right, so the square root of 25 is 5, so I need to do 5 cubed. And then the square root of 64 is 8, so I need to do an 8 cubed. So just check your power table there quick and see what we get. 5 cubed is 125. And then 8 cubed, 8 times 8 times 8, I believe, is 512. So double check and make sure. So this idea of a negative exponent, no big deal. We can handle that. It just means reciprocal. It means 1 over. So do that reciprocal and handle those powers the same way. All right, see if we can go the other direction. We spend a lot of time talking about how to go from something that was written with a exponent, right, a rational exponent, and writing it as a radical. What if it's written as a radical? Can you write it with a rational exponent? So I'm just going to put in some numbers here. What root is this first letter A? Well, that's a square root, so I'm going to go ahead and kind of emphasize that that's 2. And then it's raised to 37 to the first power. So how can I rewrite that? Well, let's just write it as that form. So we're going to have a base and raised to the power over the root, right? So the base, whatever our base is, and raised to that exponent. So I'm going to replace here with our color coding, power over the root. All right, so see if we can rewrite this one. So what that would look like. So my base in this one is the 37. And the fractional exponent that I'm going to be raising it to, well, the power is 1 over the root, which is 2. So that would be 37 to the 1/2 power. And if you're not sure, you can try it in your calculator again, right? Type in square root of 37. So I can type that number in and just double check and see that's not a perfect square. So it's going to be a decimal, yucky, right? And then try 37 raised to the 1 divided by 2 power and see if you get the same thing. We do, so we know that those are equivalent. So being able to go back and forth is super handy. All right, let's take a peek at the next one. So my base, let's see if we can identify that, is the 9, right? So I have my base, so 9 raised to the, and it's going to be power over root. So power and root, kind of color code here. So 8 divided by 4. Now, for a lot of people, I mean, if that's something you can reduce, we probably would think we should do it, and I guess I would too. 8 divided by 4 is 2, so this is the same as 9 squared. You can actually evaluate that. 37 to the 1/2, I probably can't do in my head, but 9 squared, I could go all the way to 81 with that. So if it's something that makes the calculation easier, that's why it's nice to be able to go back and forth. All right, well, you can do it with variables too. Right? We can do the same thing. And this we couldn't type into our calculator. We just have to know what's happening. We did a little bit of this in 8.1. So Z is my base. And then I'm going to raise it to, we have our power and our root. So it would be to the 8 over 8. In other words, how do I divide 8 things into 8 groups? How many would be in each group? Well, one thing. 8 divided by 8 would just be Z to the first power, or just Z. So we did talk about a little bit in 8.1 how we break that up, but we can just do that shortcut, right? It's power over root. It's division. We're taking that base and dividing it into equal size groups. That's really all radicals are, is being able to figure out how many times by itself are we dealing with here. All right, to finish up, let's talk about some operations then that we can do. What's the advantage of having rational exponents? Why is this a helpful thing? Well, we can use our exponents rules then that we were using before. So we'll start with this product rule. This is all the way back to chapter 5. If you want to take a peek at the rules for exponents, chapter 5, that notes packet has everything that you need. If I multiply with the same base, that's called the product rule. Remember, I add the exponents. So 3 to the 1/2 plus 1/3. Now, with radicals, this would be kind of gross to deal with things that don't have the same power and root. It gets kind of complicated, it gets kind of messy, but with the fractions, I can just add the fractions together. So 1/2 plus 1/3, we can just do that arithmetic. 1/2 plus 1/3 is 5/6. So I get a common denominator. Feel free, just go ahead and use your calculator. Just understand we're adding because it's the same base. So when you multiply, then we can write that over. And I could rewrite that as a radical too if I wanted to. All right, what do we do if we divide? If you're dividing things with the same base, we subtract the exponents, right? So we're going to be subtracting. So it'd be 7 to the 2/3 minus 4/3. All right, so be careful on that. 2/3 minus 4/3. So same denominator already, so we can just kind of do it in our head. 2 minus 4 would be negative 2/3 power. They want you to assume or write your answer with positive exponents. So I have to rewrite this because I can't have that negative up there if they want a positive. Remember what a negative exponent means? Reciprocal. So that just means 1 over 7 to the 2/3. That's all they want you to do, though, is just be able to rewrite it and understand that you can do these operations with our fractional exponents. Oh my goodness, look at all the stuff going on here. This is the power rule where you take everything on the inside and raise it to the 6th power. I think we can do a little simplifying first, though. I see something that we can do with the b's, so we can probably deal with that, or we can do a little bit of just multiplication and things first. We can decide what might be the easiest. Uh, let's see if we can take everything to the 6th. So do you remember what the power to a power rule is? You multiply the exponents. So let's see if we can do that for each one. So let's take a look at the first one. A to the 1/3 to the 6th. So a to the 1/3 to the 6th. And then we have a b to the 2/3 to the 6th. And then we have on the bottom, we have b and then to the 6th, and then we can simplify. So let's take a peek and see if we can do each of those. Power to a power, we multiply. So 1/3 times 6. So 6 divided by 3, basically, which would be an a squared. 2/3 times 6. So 3 divides into 6 twice, times 2 would be b to the 4th. And then it looks like we just have a b to the 6th in the bottom. You could simplify the b's first and then raise it to the 6th, or you can raise it to the 6th first and then simplify the b's, which is what I'm doing because I thought maybe I can get rid of some of those fractions, make it a little bit easier number to deal with. Where do you have more b's, top or bottom? Looks like I have more in the bottom, and how many more? That would be 2, so b to the 2nd down there. Or do the rule, right? 4 minus 6 would be -2. But remember, negative exponent, that means reciprocal, they end up in the denominator. All right, last one, distributive property, right? So we need to multiply through, right, whatever's in the outside to everything on the inside. So it's r to the 2/5 times r to the 3/5 plus r to the 2/5 times r to the 8/5. So just showing that we can do operations with things that have fractional exponents, and we do the same thing if they weren't a fraction. We multiply through, we add the exponents now, same base, right? So 2/5 plus 3/5 would be 5/5, and then 2/5 plus 8/5 would be 10/5. And then I can do a little bit more simplifying here. 5/5, that's 1, so r to the 1st, and 10/5, that's 2, so r to the 2nd. So it ends up being r plus r squared. Now those aren't like terms, right? They have different powers, but we can put them together. So the whole idea is we can do operations with the exact same rules that we did with whole number exponents with the fractional ones. So the big picture idea today is being able to go back and forth between radicals and rational exponents and be able to do operations with them no matter what. Just remember that number on the top for a fractional exponent, always the power. The number on the bottom is always the root. It's how we represent the notation we've chosen to represent fractional exponents.